How do power generators maintain stable voltage output? Imagine a power generator as the heart of an electrical system, pumping out energy that keeps our homes, businesses, and industries running smoothly. But have you ever wondered how it keeps the voltage steady, even when demand fluctuates? Well, it all comes down to a clever system called the excitation control, which works tirelessly behind the scenes. Power generators keep their voltage stable mainly through their excitation system. This system controls the magnetic field inside the generator's rotor, which is like the engine's magnet. When the magnetic field is strong, the generator produces higher voltage. When it's weaker, the voltage drops. So, maintaining the right magnetic strength is key. At the core of this process is the automatic voltage regulator, or AVR. Think of the AVR as the generator's brain. It constantly checks the output voltage and makes tiny adjustments to the excitation current flowing into the rotor. If the load on the generator increases, causing the voltage to dip, the AVR responds by increasing the excitation current. This boosts the magnetic field and brings the voltage back up. If the load decreases and the voltage starts to rise, the AVR reduces the excitation current to keep things balanced. There are different ways to regulate this excitation. Older generators use electromechanical regulators, which relying on mechanical parts to adjust the magnetic field. These are simple but not as precise. Modern generators use electronic regulators, which are faster and more accurate. These solid-state devices use transistors and diodes to control the excitation current quickly, ensuring the voltage stays within tight limits. The excitation system is powered by a direct current supply, often from an exciter. The exciter can be a small generator or a static power supply that feeds the rotor. The AVR manages this supply, adjusting the current based on real-time voltage readings. Since the generator's speed is usually kept constant by turbines or engines, the main factor influencing voltage is the excitation current. Voltage regulation is also vital for handling changes in load. When many devices turn on at once, the generator must adapt quickly to prevent voltage drops. Similarly, if the system experiences disturbances, the regulation system steps in to stabilize the voltage. In large power plants connected to the grid, the excitation system also helps control reactive power, which is essential for maintaining overall system voltage stability. Modern digital AVRs even record data and diagnose issues, making maintenance easier and more reliable. So, in essence, the stability of a power generator's voltage output depends on a finely tuned feedback loop, where the excitation system and automatic voltage regulator work together to keep everything running smoothly, no matter how much power is being drawn.